afternoon, everyone. We're going to take another look at this circuit where we powered the logic below ground. Now, from a power supply, I had ground connected to pin 14 VCC, and negative of that power supply, negative 5 volts of that power supply connected to ground, so that this 74LS00 was residing below ground. Not 0 to 5, but negative 5 to 0, so that a logic high would be at ground and a logic low would be at negative 5. Now, I'll provide a link to that video so you can go and watch that again if you hadn't already done so. But that's a fascinating circuit. So I asked myself, what if I want to go back to positive 5 volts? How do I get back to positive 5 volts? So I added this optocoupler circuit right here, so that when we have two highs, a high here which is actually ground and a high here which is actually ground, the output will be low, a 0, a logic 0. So we have a high, and a logic 0 right here. Now that allows current to flow through this 560 ohm current limiting resistor. We got to have that in there so we don't burn up that LED inside the optocoupler. Current flows from ground. Remember, we're going negative. It flows from ground through the current limiting resistor, through the anode cathode junction of the LED inside that optocoupler, and to the input pin 3, well, actually an output, a logic output, and which is at negative 5 volts now, because we have, this is actually ground, negative 5. Current flows through here and turns on that LED, which emits photons into the base of that phototransistor, causing that phototransistor to go into saturation and conduct. So from pin 5 collector to pin 4 emitter, we'll basically have 0 volts. Not quite, but real close to it. And this point right here, where our digital multimeter, the second one, is connected, will go 0 volts. Now, when any of these inputs are at negative 5, the output is going to be at ground. So any low on the input will cause that output to be at ground. Is that backwards? It sounds wrong, doesn't it? Because we are operating below ground. It sounds funny. So we have a negative 5 here or a negative 5 here, or both at negative 5. The output will be at ground. That's crazy. And when it's at ground, we no longer have current flow through this input LED of the optocoupler, part number CNY17-2. And at that time, the phototransistor will be off. It won't be conducting. It won't be in saturation. So now the DMM will be pulled up to plus 5 volts, and we will see a high, a logic high, on that second digital multimeter. I still have the first digital multimeter connected right here so we can see the swing from ground, negative 5, to a positive or 0 volts up here. So we're negative over here. Ground is at negative 5 volts. And we are positive over here. We're below ground over here on this side of the optocoupler, and we're above ground over here on this side of the optocoupler. I have two separate supplies, one to make the negative 5 volts on this side, and one to make the positive 5 volts on that side. Now it's going to look a bit odd because the first digital multimeter, the black lead, is set to negative 5 volts DC down here, and the red lead is up here, so it won't be backwards. We won't be going from negative to 0. It will look like a normal output. It will be going from, this point will be going from 0 to 5. Now let's step back and we'll perform the experiment. I've already got the circuit set up. This power supply right here is providing the negative 5 volts DC to that 74LS00. Ground is connected to pin 14 VCC, and negative 5 volts is set up and connected to pin 7 ground. How does that work? That works. Now this power supply over here is on the output side of the optocoupler, and it's providing 5 volts for that NPN transistor, that photo transistor inside that optocoupler. The 5 volts is connected to the 1 kilo ohm resistor, and the other side of the 1 kilo ohm resistor is connected to the collector of that photo transistor, and we're looking at it with this digital multimeter right here. This digital multimeter is connected to pin 3 of the NAND gate. What else is there? Oh, yes, ground of this power supply is connected to the emitter of the photo transistor. Now let's get closer to these digital multimeters, and we'll watch their state change. And I changed the 2 input states to that NAND gate, which is below ground. We'll power it up. Negative 5 volts here, and positive 5 volts here. Now right now, both NAND gate inputs are at a logic low, a negative 5 volts. And we can see that pin 3 of that NAND gate is at a logic high. We have 4.507 volts, logic high on the output. The photo transistor's collector is high, and that is because the LED inside that optocoupler is not turned on and emitting photons into the base of that photo transistor. Now, we'll set pin 1 high, which is actually ground, and we see no state change. Let's set pin 2 high. Still no state change. We have 4.5 on the output of the NAND gate, and we have 5 volts on the collector of the photo transistor inside that optocoupler. Now, both inputs are going to go high. Both inputs are at ground right now. We have to think backwards because we're below ground. Ground is actually high, and a low is actually negative 5. So at the output of the NAND gate, we've gone low. We have 288 millivolts. That allows current to flow through that LED circuit inside that optocoupler. And the photo transistor on the output side of the optocoupler has gone into saturation. We have 257 millivolts between the collector and emitter of the output side of that optocoupler. Let's take one input negative again. Take both inputs negative. We've gone high on the output of the NAND gate, pin 3, and we've gone high on the output of the optocoupler, pulled up by that 1 kilo ohm resistor to positive 5 volts DC. Let's take both inputs low again. Take an input high. Take both inputs low. Look at that. So that's one way we can get from below ground, operating below ground, to operating above ground with that optocoupler separating the negative 5 volt DC side and the positive 5 volt DC side. There you go, all. Hope you enjoyed that. Our 4th of July is coming up here shortly. What is it? Oh, it's tomorrow. Okay. I'm taking tomorrow off and spend a little bit of time with the family. I hope y'all are too. It's always good to have family. Enjoy the day, y'all. We'll see you next time.